Question 4. We can see that this one is our first long question with a bunch of parts. We're going to do the full hypothesis test for this question. So let's get to it. A manufacturer of mountaineering equipment produces 3-strand climbing rope on 2 separate production lines, line 1 and line 2. The manufacturer regularly tests the tensile strength of its ropes by randomly selecting ropes from the production and subjecting them to various tests. The results from the most recent random sample of ropes are shown below. And we have line 1 and line 2. We've got sample means for both. We got sample standard deviations for both. And we have sample sizes for both. Looking at this, the fact that we have sample standard deviations, S's instead of the sigmas, tells us that this is going to be a 2-sample t-test, not a z-test. Sigmas, Greek letter sigma, would indicate a population standard deviation, which would indicate a z-test. The fact that these are sample standard deviations indicates a t-test. So assuming that the population of tensile strengths from each line is approximately normally distributed with equal variances, that's a key phrase, with equal variances. When we're doing a 2-sample t-test, we could assume equal variances or unequal variances. Those are called pooled and unpooled t-tests. And so this one, assuming equal variances, the question tells us, means that we're going to be doing a pooled t-test. Can the manufacturer conclude that there is a difference between the mean tensile strengths of ropes produced on the 2 lines? Conduct the appropriate hypothesis test at the 0.10 level of significance. Right, so this sentence is very important. Conclude that there is a difference. That's going to be the key phrase that we need to do our very first part. What are the appropriate hypotheses to test? The fact that there is a difference is the phrasing used, means that we're not looking for a difference in one direction or another specifically. We're not looking, is line 1 better than line 2, or is line 2 better than line 1? We're looking generally for, is either one better than the other? So we're looking for mean 1 minus mean 2 equals 0 versus does not equal 0. And that's going to be F right here. Mean 1 minus mean 2 equals 0 versus does not equal 0. That is, the null hypothesis says there is no difference. The means are equal. That's why mean 1 minus mean 2 would equal 0. Versus there is a difference. They're not equal. And we choose F over D because F has the appropriate one selected as the null hypothesis. D's null hypothesis has a not equal sign, and that's impossible. A null hypothesis will never have a not equal sign. A null hypothesis could only have an equal sign. So D could never be the answer to any question. And F is the answer to the question here. For part A, determine the rejection region needed for the test statistic T. So because we're doing an equals versus not equals, this is a 2-tailed test. If we were looking at one of these other ones with less thans or greater than, that would be a 1-tailed test. That would be like B or C here. We could be looking at greater than or less than, whichever one agreed with the alternative hypothesis. But our alternative hypothesis is not equal to. So for that reason, not equal to means it could be on either side. We could be dealing with something greater than or less than. That's why we're picking A. So we have our 2 tails, and now it wants us to fill in the 2 blanks. What are the 2 blanks going to be here? Well, this is going to be our critical values. So to get the critical values, we need the calculator. So we bring up the calculator. And we go into stats mode. For critical values, we do not go to test. We will go to test later for the hypothesis test. For critical values, we go to dist, distribution. That's F5. And then in this case, T, because it's a t-test, like we said. And then for critical values, we're always doing inverse. So inverse T. Okay, so now we have this ready here. We need to put in the area. What is the area? The area is going to be the level of significance divided by 2 because it's a 2-tailed test. So we're going to put in 0.10 divided by 2 In other words, 0.05. I typed something wrong. There we go. I don't know, something wasn't working when I was typing, when I was clicking. But anyway, 0.05, right? So 0.1 divided by 2. And then what's the degrees of freedom going to be? The degrees of freedom for something like this is going to be our little formula here. The degrees of freedom is going to be n1 plus n2 minus 2. And this is for any pooled t-test, right? So the fact that they said that we're assuming equal variances means we're doing a pooled test, which means we're using this degrees of freedom. The unpooled degrees of freedom is much more complicated, and maybe we'll see that later, but for this question, we're not worrying about that. We're just doing these. All right, so what's this going to be? Looking at our question, it's going to be 20 plus 35 minus 2. So 53. And then we run this and we get 1.674. So when t is less than negative 1.674 or greater than positive 1.674, or it wants 4 decimal places. Pay very close attention to how many decimal places it wants. So we have to keep 6741. We have to keep the 4th decimal place. That's fine. All right, so just to draw the picture of what's going on here, the idea is, here's our distribution. We have 2 tails. Up here, this area is 0.05, and this area is also 0.05. And so when we look up an area of 0.05, the number the calculator gives us, right, this 1.6741 is this value here. Which makes this value here negative 1.6741. And so the area that I've highlighted in red is the rejection region. This is the area when t is greater than 1.6741 on the right, or when t is less than negative 1.6741 on the left here. Okay, so that's our critical value section and our rejection region. Moving on, we have to calculate the value of the test statistic. And so to do that, we need to go back to the calculator and get back out of this. So click exit a couple of times. Instead of dist, we're doing test now. Test t to sample. Mean 1 not equals mean 2. That is the correct hypothesis that we're looking at. Right? That's another way of writing this alternative here. If we were doing a directional test, we would press F2 or F3, depending on which direction we were going. But we're doing a 2-tailed test, so we do this one. And now we just have to put in all the numbers they give us, right? So they gave us 7066, 425, 20, 6968, 420, 35. Pooled is on. This is a pooled test because it says equal variances. And then we run that and we get our test statistic t is 0.82887. So rounding to 4 decimal places, we get 0.8289. Now this test statistic, where does this fall? Looking at our picture, where does 0.8289 fall? Well, that's going to fall somewhere around here. Right, it's between the negative 1.6741 and the positive 1.6741. So it's not in the red highlighted rejection region. Right, so the test statistic is not in the rejection region. So we do not reject the null hypothesis. And that means that we don't have enough evidence. It's insufficient evidence to conclude the 2 population means are different. Okay, and that's how we do question 4.